Okay, guys, so for Unit 3, we worked with rules of exponents and factoring, just factoring, not solving. So let's look at a problem that deals with rules of exponents first. So I have 3x, y to the third, all of that to the third power. And all of that is divided by negative x squared, y to the third, all of that squared. Okay, when I am raising an entire quantity to a power, remember we can take that exponent and distribute it to all of the individual pieces, but what do I do with the exponents? Do I add them or do I multiply them? You multiply. So this is 3 to the third power. Please do not write it as 3 times 3. It is 3 to the third power. This is just an x, so when we raise it to the third power, it becomes x to the third. And y to the third, all of that to the third, gives me y to the what? To the ninth. We're going to do the same thing on the bottom. However, I am squaring a negative x squared. Whenever I square a negative, what does it turn into? A positive. So this is going to be positive x to the what? Good, to the fourth. Y to the sixth. Now, is this simplified? No, I can reduce some, right? 3 to the third we can do because it's small, so I'm just going to rewrite it as 27. And then look at your x's. In the numerator, I have an x to the third. In your denominator, I have an x to the fourth. So where are my x's going to end up? On the bottom. And how many of them will there be? Just one. Now with the y's, I have a y to the ninth in the numerator and a y to the sixth in the denominator. So where are my y's going to end up? On the top, and it's going to be a y to the third. You can't simplify anymore, so that's your answer. All right, example 2, we have 3x minus 4 times 2x squared plus x minus 1. What type of problem does this look like, guys? Foil or the box? How many of you are most comfortable with foil? How many of you are most comfortable with the box? Okay, it looks like we have a few more box people, so I'm going to do the box. If you are a foil person, use foil. You will get the same answer, okay? So, box people, here we go. This is going to be a 2 by 3 box. Okay, so a 2 by 3. So this is going to be 3x minus 4 on the side, and 2x squared plus x minus 1 along the top. And then we just multiply. If you are doing FOIL, you take 3x and you multiply every single term by 3x, and then you take negative 4 and multiply every single term by negative 4. You will get the exact same answer. So here we go. 3x times 2x squared, guys, what does that give you? 6x to the third. 3x times x gives me 3x squared, and 3x times negative 1. Negative 3x. Let's do the bottom. Negative 4 times 2x squared, what's that give me? Good, negative 8x squared. Negative 4 times x.
Negative 4.
Thank you, negative 4x. And negative 4 times negative 1?
4.
Positive 4. What is our last step?
Combine like terms.
Combine like terms. 6x cubed does not have a like term, so that's all you can do there. Negative 8x squared plus 3x squared, what's that give you?
Negative 5x.
Perfect. Negative 4x minus 3x?
Negative 3x.
Negative 7x. And then plus 4. Guys, question. In multiplication, does order matter?
No.
No. So if you have the trinomial in front of the binomial, can you still do FOIL? Okay, so it's still the exact same. Okay?
Is that the answer, or do you need to factor that more?
If you factor it, you would undo exactly what you just did.
Okay, so you leave it like that?
So you leave it like that.
Ah.
Yep. Because foiling puts everything back together, factoring takes it apart. So if you factor it, you would end up with what you started with.
Okay.
Long division. 2x minus 1 divided, or goes into 4x to the third plus 6x squared minus 2x plus 3. Okay, with long division problems, while you guys are finishing up writing, we needed to make sure that there are no holes in our polynomials. So I have 2x, and then it goes down to a negative 1. Am I missing any terms in here? Okay. What about x cubed, x squared, x, and then nothing? Am I missing anything there? So do we have to put a placeholder? Okay, good. So let's get started. Remember, we always look at the first term and try and match it to the next term on the inside. So 2x, I want to turn it into a 4x cubed. What would I multiply by?
2x.
Good, 2x squared. So you take 2x squared, write it at the top, and then you multiply everything in what we call the divisor into 2x squared. So 2x squared times 2x gives me 4x cubed, and 2x squared times negative 1 is minus 2x squared. Now, guys, think back on your long division that you learned in 3rd grade. After you multiplied, then what did you do? You subtract. So when we subtract an entire binomial here, that's going to change the signs of everything. So this becomes a negative, and negative 2x squared becomes a positive. Because multiplying by a negative changes the signs of everything, right? Okay. So 4x to the third minus 4x to the third, that cancels, which is what we wanted to happen. And then 6x squared plus 2x squared gives me 8x squared. Bring down the next term, so minus 2x. And then you're going to do it again. 2x times what gives me 8x squared? 4x, so make sure you put plus 4x. Multiply 4x by everything on the outside, so 4x times 2x gives me 8x squared, and 4x times negative 1 is minus 4x. Change the sign, so 8x squared becomes negative, negative 4x becomes positive. So our 8x squared cancel, and we are left with 2x. Bring down the plus 3. Guys, 2x times what is going to give me 2x? 2x times 1. So put a plus 1. 1 times 2x minus 1 is going to give me 2x minus 1. When you change the signs, we are left with a remainder of 4. What do you do with your remainders? You put it over the outside. So this is 2x squared plus 4x plus 1 plus remainder 4 over 2x minus 1. And that is your answer. If everything ended up canceling out and we had no remainder, you would stop there and you shouldn't get a remainder at all. Okay? If you end up with a remainder, you put it over the outside. Okay, guys, I want to factor this one. I have 8x cubed plus 125. Does this pop out as any kind of factoring to anybody? So, cubes, same thing. Now, whenever you have a sum of cubes or a difference of cubes, I want you to first, before you do anything, rewrite the problem so that we can see what the bases are. So 8x to the third, how would I rewrite that so that it's one quantity, all of that to the third power? 2x. So one of your bases is 2x, And 125 is what? 5 cubes. So now that you have all your bases, now we can fill it into soap. So remember, to do soap, you make a small set of parentheses, a larger set of parentheses, same, opposite, always positive. In the small parentheses, you just put your bases. So we have 2x and 5 go in there. In the larger parentheses, the first and last term are your bases squared. So this base, 2x, the whole thing of it is being squared. So it's 2x squared. The last one is going to be 5 squared. And then does anybody remember what you do with the middle? You multiply them together. So 2x times 5. Obviously, this is not simplified form, so let's simplify it. 2x plus 5 times 2x, all of that squared gives me 4x squared minus 10x plus 25. I guarantee if you are using cubes or soap to factor, you will not be able to factor any more than that. Okay?
Wait, you explained the...
So example 5 is a difference of cubes, but it's pretty much the exact same problem, but I want you guys to try it on your own. You can work with the people in your group. We'll check our answer in just a second. Alrighty, before we can plug everything into soap, you need to rewrite 27x to the third as a, not a quantity, but as a base. What would the base be? 3x. And then y to the third, y is your base, so you don't have to worry about that. So you have a small parentheses, you have a big parentheses, same, opposite, always positive. So then we just fill in the blanks. Ladies and gentlemen, what goes in the first blank? 3x. What goes in the second? I know more of you know this than how many are answering. What goes in the next blank? 3x squared. The middle. And the last one? Okay. Is this simplified? No. 3x minus y. What would 3x squared be? Good. 9x squared plus 3xy plus y squared. And that's your factored answer. Not too bad? Okay. So that's cubes. Let's look at a different method of factoring. Example 6. Okay, I have 4y squared minus 16x squared. There might be a couple different ways to do this one. Does anybody have a thought? GCF? Anything else? Difference of two squares. You can do either one. What you need to remember, though, is because there is a GCF, if you do difference of two squares first, you will have to factor out the GCF at the end. So a lot of times it's easier if you take out the GCF first. Okay, so I always want you to check for a GCF first. In this case, we have one. What is it? 4. So factor out the 4, and that leaves you with y squared minus 4x squared. So we still have a difference of two squares, right? Okay. So we set up two parentheses. One has plus, one has minus. And then we take the square root of everything. What is the square root of y squared? Okay, so these are both y. And what is the square root of 4x squared? 2x. And you're done. In this case, sometimes you can do difference of two squares twice. Okay, but always check for GCF first. Okay, any questions so far? Okay, we have two more factoring. X plus 7 squared minus 36. I don't know about any of you guys, but this kind of looks like a difference of 2 squares to me. Does it look like a difference of 2 squares to anybody else?
Yeah.
The only thing that's different is that we have this x plus 7. Can I substitute something in for x plus 7 that will make the difference of 2 squares a little more obvious? Well, we can't use x because it's already being used. Y, A, we used A. It doesn't really matter. You can use D for Dodson since I'm your favorite teacher. You know, Greek alphabet, sure. Sigma squared minus 36. So you let A equal x plus 7. You can use a happy face if you want. I don't care. So substitute it back in. So this is going to be A squared minus 36. Now is the difference of 2 squares easier to do. Okay, so let's do it. That would be A plus 6 times A minus 6. If you left your answer like this, it would be wrong. Why? You have to plug x plus 7 back in because our original problem didn't have a's in it at all. So plug x plus 7 back in. So this is x plus 7 plus 6 and x plus 7 minus 6. Now, when we took the test on this, a lot of you gave me this as your answer, and I had to take off a point. Do you remember why? Can you do 7 plus 6? So do it. What's 7 plus 6? 13. So this comes out to x plus 13 times x plus 1. Now you are factored all of the way. That's a method that we don't use all the time, so when it comes up, it can be hard to recognize. So just make sure that you keep that in the back of your mind, okay? Last one on factoring. 8x squared plus 10x minus 3. You guys should know this one right away. What is it? So if I'm going to use bottoms up, I still have to check for a what first? Okay, so we have 8, 10, and negative 3. Is there a GCF there? Okay, so then what would my first step of bottoms up be? Multiply 8 times negative 3. So that's going to give me x squared plus 10x minus 24. And now we can use diamond method on that. So what two numbers multiply to negative 24 and add up to positive 10? Positive 12, negative 2. Do you guys agree? Okay, so this is x plus 12 times x minus 2. But if I were to FOIL all of that, I would not end up with what I started with. What would be my next step? Yeah, you have to divide by 8. 12 and 8 both reduce by 4, so this is going to be 3 and 2, and 2 and 8 both reduce by 2, so that's 1 and 4. So bring your bottoms up, and we factor to 2x plus 3 times 4x minus 1. And you're done. So Unit 4 had to do with graphing, so especially graphing quadratics. So I want you guys to please, please, please go find your notes because those are going to help you tremendously. You wrote all of this down already, so I'm not making you write it down again. We're just doing some example problems. We started with Unit 4 by solving quadratics using the zero product property, but we also had questions in there like this, where we were asked to find the volume when our sides were binomials. So we do have a formula for finding the volume. What is it? Length times width times height. Okay, so finding the volume is length times width times height. I know my length, it's x plus, or that's your height, it's 2x plus 5. My width is x minus 3, and my height is x plus 1. So let's plug all of that in. So your volume is going to be 2x plus 5 times x minus 3 times x plus 1. So what do you guys think you're going to do? Box method or FOIL, but you're going to have to do it twice, okay? So let's do FOIL this time. I'm going to FOIL the first two. 2x times x gives me 2x squared. 2x times negative 3 is minus 6x. 5 times x is plus 5x. And 5 times negative 3 is minus 15. All of that is going to be multiplied again by x plus 1. Let's combine like terms before we try foiling again. So this is going to be 2x squared minus x minus 15 times x plus 1. And we just did a problem like this in example 1 of unit 3. The only thing that's different is the position of my binomial and my trinomial switched. But with multiplication order doesn't matter, so you can still FOIL here. I'm just going to go backwards. So your volume is going to be x times 2x squared. That's 2x to the third. Negative x times x is minus x squared. And x times negative 15 is minus 15x. And then you're going to multiply all of that again by positive 1. So that's going to be plus 2x squared minus x minus 15. Last step, we're going to combine like terms. We have 2x squared, nothing to combine with that. Or I'm sorry, 2x cubed. Negative x squared plus 2x squared. What's that going to give me, guys? X squared. Good. And negative 15x minus 1x is going to be minus. Good. And then we have negative 15 all by itself. You cannot do anything else. If you were to factor this, you would undo everything we just did. Okay? It wanted the volume, which means we multiply it all together. Okay? Not too bad? No. Okay. All right, so problem number 2 tells us that the area of a rectangle is this, 2x squared minus 7x plus 6. We know what the width is, x minus 2, so they want us to find the length. They give us the area. Remember, area is length times width, right? So we know what the area is, 2x squared minus 7x plus 6. So we want to break it up so that we can see a distinct length and a width. So that means we're going to factor. What factoring method would you use here? Bottoms up. So multiply by 2. We know that that's your area, so that's going to be x squared minus 7x plus 12. And then what two numbers multiply to positive 12 and add up to negative 7?
4 and 3.
Negative 4 and negative 3. So x minus 4 times x minus 3. But we have to do what? So 2 goes into 4 twice, and 3 and 2 doesn't reduce. So our area is actually x minus 2 times 2x minus 3. We want to know what the length is, and they give us the width, which is x minus 2. So what is your length? 2x minus 3. So our area is length times width. Example 3, they want us to find the x-intercept of 6x squared minus x minus 2. This is a parabola. The x-intercepts are where the parabola is going to cross the x-axis. Another word for x-intercepts is zeros or solutions. They all mean the same thing. So if I'm looking for the x-intercepts, I know what y equals on the x-axis. Does anybody else know? On the x-axis, what is y? 0. So let's set the whole thing equal to 0 and then solve. So what are you going to do? Bottoms up again. So let's do bottoms up. So that's going to give me x squared minus x minus 12 equals 0. Two numbers that multiply to negative 12 and add up to negative 1. Good. Negative 4, positive 3. Remember, all of that's equal to 0. Divide by 6. So that reduces by 2 to 2 and 3, and by 3 to 1 and 2. So we have 3x minus 2 times 2x plus 1 equals 0. And how do I solve for x here, guys? Set each one equal to 0. That was called the zero product property. So this is 3x minus 2 equals 0, and 2x plus 1 equals 0. So to solve, we're going to add 2 to both sides. 3x equals 2, and then we're going to divide by 3. So one of our solutions is x equals 2 over 3. How would I find the other one? So subtract 1, and I get 2x equals negative 1, and then what? Yep, divide by 2. So my second answer is negative 1 over 2. That should make sense because how many times does a parabola cross the x-axis? Twice. Because it's shaped like the U. Okay. Any questions so far? 2 more and then we're done. So example 4. I give you 2 quadratic equations, and the question is to find the vertex of each one and state whether it is a minimum or a maximum. So our first quadratic equation, y equals x squared plus 8x plus 1. We had 2 different forms of quadratics. We had a standard form and a vertex form. Does anybody have a guess which form part A is? Standard or vertex? It is standard form, so will you label it standard form? Okay. It is standard form. So to find the x-coordinate of the vertex in standard form, we had a formula. X equals, anybody remember? Negative b over 2a. What would be b? 8. So this is negative 8 over 2 times what? 1. So negative 8 over 2 gives me negative 4. That is your x-coordinate. How would I find the y-coordinate? Plug it back in. So let's plug it in really quick. Y equals negative 4 squared plus 8 times negative 4 plus 1. So that gives me 16 minus 32 plus 1, which all comes out to negative 15. So my vertex is the point negative 4, negative 15. The vertex is either the highest point or the lowest point on the parabola, or the same point where the line of symmetry goes through. So the next thing we need to do is we need to determine if this graph is a minimum or a maximum. Is this parabola opening upwards or downwards?
Upward.
Up. How do you know? Because the a squared is positive. So my vertex is this point right here. Is that the minimum point or the maximum point? That's the minimum point. Okay. So if part A was in standard form, what do you think part B is in? Vertex form. So label it vertex form. And the thing we liked about vertex form is everything was already laid out for us. Remember, vertex form, your x-coordinate is attached to the x, but you have to take the what? Does anybody remember? This says a plus 7, so what would my x-coordinate actually be, though? -7. So if it's in parentheses, you have to take the opposite. So our vertex here is going to be -7, comma. And your y-coordinate is whatever is being added or subtracted to the outside. So what's being added or subtracted to the outside in this case?
0.
A 0. So your y-coordinate is 0. That's your vertex. So much easier, right? So the only other thing we have to determine is if this one has a maximum or a minimum. Is this parabola opening upwards or downwards? How do you know? That -3. So my vertex at this point right here, is that the maximum or the minimum? Max. Okay. Please, please, please go check your notes for this because you wrote it all down already. Okay? One more, shifting graphs. Okay? The question is, how does the 3 change the graph of y equals x plus 3 squared plus 1 from the original graph y equals x squared? Okay? Whenever I have a problem like this, I always suggest graphing both and just seeing how it shifts. So while you guys are writing this down, I'm going to draw a graph. It's just a sketch. It doesn't have to be perfect. So let's graph the original one first. Here's your original graph, y equals x squared. To just do a sketch of the graph, we just need to figure out what the vertex is. So remember, the x-coordinate is what's being added or subtracted to the x, and the y-coordinate is what's being added or subtracted to the back. What would my vertex be for this one then? So your original vertex is 0, 0. So you're going to plot that. And the x squared is positive, so it's opening upwards. So that's your original graph. Now look at the new one. Y equals x plus 3 squared minus 1. What would the vertex of that one be? -3, because you have to take the opposite. And what's being added or subtracted to the back? A 1. So -3, positive 1. So you're going to go left, 1, 2, 3, up 1. Make it as close as possible to the other one. So then the question is, how did the 3 shift the graph? What did the 3 do to the new graph? It went to the left. How many spaces? 3 spaces. But it's just asking about the 3. So just the 3 affected it to the left. So it shifted or shifts left 3 units. How did the 1 affect the graph? It went up 1. Okay? But the question was just asking about the 3. Okay? That was Unit 4 in a nutshell.